The gas-oil ratio of a fuel is, you guessed it, the ratio of gas to oil. It typically has much more gas than oil in the fuel.
Motor oil is made from heavier hydrocarbons, often with 18 to 34 carbons per molecule. So it'd be like there's an H, and then a C, and then an H, and then another H, and another C, H, and an H, and then some proprietary formula stuff.
Oh dear.
And then another C, and an H, and an H, and keep going like that until you got 18 to 34 carbon molecules. And the number of carbon molecules depends on the viscosity of the liquid. Oil is meant to be very viscous, which means that it's going to take a lot of pressure in order to make it move. And oil is also meant to have viscosity change very little with temperature. Oil also has a flash point, which is the temperature that it will spontaneously catch on fire. The Society of Automotive Engineers give grades or weights to oil. There are two separate grades for cold and for warm application. Big numbers are thicker, more viscous oils. Oils often change viscosity with temperature, so it is important to have a high viscosity index, which means that viscosity doesn't change much with temperature. A low viscosity index would have a large change in viscosity, which is bad for the engine. In an engine, the oil needs to be really viscous, or else it won't do its job of lubricating the parts properly. And disposing of oil is an environmental hazard, so don't go dumping it in streams. In engines, the piston moving up and down creates energy from the fuel. While the piston is moving up and down, it has friction with the surrounding areas. This friction wears down the metal parts, increasing fuel consumption because of the extra waste heat and decreasing engine efficiency. This degrades the engine and will eventually lead to the engine not functioning like an engine, but rather as an ornately shaped chunk of metal. Motor oil solves this problem by reducing the friction between the piston and the walls of the container. Once the coefficient of friction is reduced, more energy is transferred into the power of running the car and less is released as waste heat. Oil also transfers waste heat away from the piston through convection so that the engine can run efficiently. In oil, in addition to the nice hydrocarbons, there are many useful compounds such as antioxidants and cleaners. The engine can clean the engine by removing burrs and other small metal fragments that are produced because of friction that would wear down the engine, thus turning the oil black. Oil is either recirculated through the engine if it is a large engine, or if it is burned with the fuel, which is common in two-stroke engines. There is a specific oil-to-fuel ratio, and that ratio allows for the peak performance of the engine. If the ratio of fuel to oil is too high, the engine will be burning extra oil, which isn't as fuel efficient as burning the right ratio. And then if the ratio is just straight gas and no oil, there are problems.
Running an engine without oil is a pretty bad idea. The parts will start to seize up and break, and since there's no cleaners inside the gasoline, there's no way to clean all of the excess gunk out of there. So the engine will start smoking excessively, like you'll see in the upcoming videos, and the engine is so hot that sometimes the metal parts will fuse together, thus completely ruining the engine forever. It's generally not a good idea if you're looking to save money.
And here's the damage on the piston and rings. You can see that they're all scored.
And I think that that is the end of this poor car. Quite a violent death as well, I wasn't expecting that.
First of all, look at the small amount of oil that didn't quite make it out while draining. It's quite dark, and this is after a 15-minute run with oil and 15 minutes without in a brand new engine. I kept the oil which I drained out after the first test, and you can see it here on the left. On the right, the oil which remained in the drained engine. Clearly quite dirty, and actually it has quite a bit of metal content in it, as you can see reflecting as I move around the towel. Significant wear of the engine occurred, whereas the oil on the left is perfectly clean and clear. On the left we can see a brand new cap, and on the right after 30 or so minutes of running, with half of that time in an engine without oil. You can see the smooth, shiny surface on the left versus the scored, less reflective surface on the right. Indeed, you can see the scratches on the crankshaft as well. I would also expect to see similar issues with the camshaft and cylinder bore.
So do not ever run an engine without oil in it.